Alright, let's get this stuff taken care of really quick. A polyhedron in which one face, the base, so put, right, the base, it's supposed to be two words, but mine looks like one word. The base can be any polygon, and the other faces, the lateral faces, are triangles. I guess that might be important, the triangles part and the polygon part. Okay, all lateral faces meet at a common vertex. Called the apex. What a cool word, apex. It's almost as cool as apothegm. Apothegm. Okay, you name a pyramid by the shape of its base. And pyramids actually only have one base. You guys will probably notice that really quickly. This one right here is called a hexagonal prism, or pyramid, sorry. Hexagonal, because it has 1, 2, 3, 4, 5, 6 sides. This one right here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, so that's a decagonal prism. Decagonal. That's kind of a funny word. Decagonal. Alright, vocabulary. Still got a little bit more. A polyhedron in which one face... Wait, we already did this one. Yeah. Okay. So he's like reading it like it's brand new. A pyramid whose base is a regular polygon. I'm just going to say I'm going to say reg poly, and whose lateral faces are triangles, is a regular pyramid. I'm going to say triangles like that. Okay, that's what that is, a regular pyramid. The altitude of a pyramid is the perpendicular segment from the base to the apex. Look at my apex. Well, that's kind of weird. No. Oh my God. The altitude is the height. AB in this picture is your altitude / the height. See, there's the apex right there. The points at the top of the pyramid. Notice that your height goes straight to the middle of the base. Alright. Let's see what we got here. The length of the altitude of a lateral face is called the slant height. See, it's right here. If you want to draw a slant height, what you have to do is you have to find the middle of a line, and then you have to start from the apex and go straight down to that point. Three-dimensional figures are always kind of weird to me, but if you know where your line's going, it looks actually kind of nice when you're done. And then if you want to draw the you know how you draw the, what's that thing called? The little square thing right there to show that they're perpendicular. Make sure it's parallel to your sides. Like whatever line you draw, like this is parallel to that line. And then it looks nice. You can learn that in art class, I'm pretty sure. Can you guys draw two different nets for this pyramid? One's a net that I'm pretty sure you guys would draw, and then the other one might be interesting depending on who you are. Draw two nets. Alright, let's look at one of them. Alright, here's one that you guys should have drawn already. Because we did an activity that had you draw one, and most of you guys drew it like that. But can you draw another? Last class, someone came up with this one. I kind of liked it. We draw the square base, and then check this out. You do that, and then you go like this. And then so this side would have one of those also. Kind of cool, huh? It would work.
That's tricky.
I think the more difficult one to do would probably be to label all the points. Let's label these right here. This one would be C, D, and then A, and then B. F goes right there, and right there, and right there, and right there. Did I label all the points here? I labeled all the points, right? Okay, oh yeah, I didn't label O. There's O right in the middle. Okay, for this one, O would be in the middle, but this one's kind of interesting because you have doubles of others. How come F is doubled right here? Because they're all the same point. Yeah, you're right.
It's the top one.
Yeah.
It's the apex.
Okay, but it's the apex. Oh. Okay, we have a C, D, and an A, and a B. Okay, what would this one be right here? What point would that be? That's right, F. And this one would be B, and this one would be A. Ooh, A got repeated this time. Here's F again. And then we have C, and this would be B. You guys agree?
Yep.
Alright, that's a cool net. Alright, now let's try some problems. I'll give you guys your formulas and we'll do some problems. Now lateral area, we did this yesterday. You guys remember doing lateral area? Lateral area yesterday when we were doing prisms was what do we have to do? I think it was 1/2 perimeter times height, right? Or it was altitude, but let's just stick with height. 1/2 perimeter times height. Now for the prisms or the pyramids, however, we don't call it height. We call it slant height. So it's not going to be the H. It's going to be 1/2 the perimeter times the slant height. And then for the other one, the surface area, that's going to be the lateral area plus the area of the base. Let's say that. B equals area of base. L, do you guys know what L equals? Slant height. And then P is your pyramid. No, not pyramid. What am I doing? Perimeter. Find the lateral area and surface area of this dude. Oh, that's a great practice. Let's try it. Alright, so we have our lateral area first, and all we need is 1/2 the perimeter times the lateral area. No, the slant height. Okay, what is my perimeter of this base? This is definitely 16, that's 16, that's 16, that's 16. What is that? 64? Is that right? Yeah. Yeah, that's right, that's right. Okay, what about the slant height? Does it give it to us?
10.
Yeah, it's right there. You see the height of the lateral shape right there? It's 10. I'm going to multiply, let's see, 1/2 times 64, that would be 32. And then I multiply it by 10, that would be 320. That would be the lateral area. That's just the area of the side figures, the triangles. And that's going to be inches squared. What about our surface area? How do we do that? Well, we're going to take 320 and we're going to add the area of the base, right? 320, add the area of the base. What is the area of this base right here? 16 times 16? What is 16 times 16? So well, let's write it out. Let's be all thorough and stuff. So 16 times 16 is 1056. Is that what you said? 256. So plus 256. And if I add that to 320, I get, what is it? 76. Yeah, I agree. Inches squared. That is your surface area, and that is your lateral area. 2. Okay. Hey, I have a question for you guys. Now, this is going to happen a lot for your problems. What if the slant height wasn't given to you? How could we have found it? You see the slant height right here? What if it wasn't given to you? How could you find it?
Find the base.
Find the base? Wait. How?
Treat it as an opponent.
How?
I don't know.
You don't know?
16 minus 6.
You do 8.
Base minus the
8 squared plus 6 squared.
center.
Use triangles, guys. Pythagorean Theorem.
8 squared plus 6 squared.
Okay, look. Here's one triangle. Let's use orange. Just make it pop a little bit. Here's one triangle right here. Okay, if you didn't know that this was 10, you can use 6, and what's the length of this side? Yeah, it's 8. It's exactly half of the 16. How do we know that? Because that point is in the middle. So we can use Pythagorean Theorem for this. Yeah? Now, is there another triangle I could use it for? This one right here. Can I use the Pythagorean Theorem for that? Yeah, we know this is 8 right there. So there's different triangles you can use. Use triangles. That's how you'll find the length of the slant height if you're not given it.